And again, the ranking is the most positive to the most negative. So you should pay attention to sign here a little bit. Let me see if I can help a couple other friends out with this. So if you look at A, my position at the end is 25 meters. My position at the beginning is also 25 meters. So if I apply this idea of initial plus change equals final, I'm going to have 25 plus what equals 25 meters. Yeah, so my change here, aka my displacement, is 0, okay? So think carefully about where A and B rate out into this thing. If C is 10 meters, A is 0 meters. And we're still kind of in the same boat. Again, I hope you're in here. I can't tell. Looks like everybody's back in, or at least a lot of people are back in. Some people have C out front. Some people have D out front. Some people have F out front. So I need you to chat with your neighbor in your little online in-person classroom there. Because I'm definitely seeing a most popular answer, but there are still some folks that have F out front, have D out front, have C out front, have A out front. Try to get a little consensus going in your neighborhood.
This one is 0 and 10. So when you do up there, but it's going by the so like this, the first one be 3 and the second one will be 10. Yeah. And this one would be 18. Yeah. It might be like negative. And this would be 0. 1. And this would go by the last one. Like 6. Okay, so you're always looking at like this way. Okay, 0 and then 10 and then this will go like 5. Okay, kind of does that 5 of it. So then you have to put it in this side. And you should question it is hard. So if you really want to
All right, I think we're kind of forming a clear consensus here now. So if you look over here, there are some variants, but a lot of it is C greater than D greater than F, then A equals B, and then most folks have E on the backside. So if you're not 100% on that, maybe have a conversation with your neighbor, but that's kind of where things are trending. C greater than D greater than F, A equals B greater than E. So let me grab that.
This one would be 5 and 5. Or so then equals 0 because equal. And then this one. Okay.
if we take a look at E, my position here at the end, now the time is 10 seconds. That's what the bottom numbers tell me. But the position is 0. The position here at the beginning is 15. So if I go 15 plus what equals 0, that's telling me that the change, yeah, it's got to be negative 15 meters. So that's how folks are ending up with that as the most negative. All right. This is when we're talking about displacement. Displacement is the change in position. The other thing we might talk about is distance, the odometer reading, okay, or step counter. So think about this. If I start here, this is 0, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then go 1, 2, 3, 4, 5, are my distance and my displacement equal there? That's what I need you to chat with your neighbor about real quick. Okay? So if you're just wandering back into the bathroom, here's why I start. I start at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Compare and contrast there with your neighbor, the distance that I just walked and my displacement. Okay. 10 steps, 5 steps.
Yeah, I think it's probably not. Yeah, and like we're not tracking it.
And so let me throw this to you. For that motion, are my distance and my displacement equal? Yes, no. That's what I'm asking. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Distance and displacement equal. You're throwing a yes, no on the thing. I've only got about a 30 in right now. I mean, have a chat with your neighbor if you need to, but then let's get in so we can get on. Got about half you.
I finished this coffee. I didn't even get to this first time.
Okay. I've only got about half here right now. I'd prefer to have more. The question was, when I do that 10 steps this way and 5 steps back, how do my distance and my displacement compare? I got one friend saying that they're the same. I got, now we're voting. Yeah, you just needed to show us where the majority was, Mr. Harding. Nah, bunch of sheeple. All right. So now we got 18 saying yes, that they're, or I'm sorry, we got 18 saying no. Now we got 20 saying no, that they are different there. All right. So friends, what is my distance walked if I go 10 and then 5? That's 15. What's my displacement if I go 10 and then 5? It's 5. Okay. So you got to look at if we're talking displacement, you're just looking at the beginning and end point. If you're talking distance, you got to pay attention to every step of the way. So with that in mind, what I'm looking for you to do on that sheet right now is rank based on distance. It says their odometer reading, but it means distance or Fitbit. Rank those based on that. I want to make sure we've got these two terms distinguished. If I ask you distance or I ask you displacement, are you able to differentiate?
I know, she left at 8:40. Yeah.
Hard exam.
Hey, you did get a B after.
Yeah, but like a lot of people like still and like work on their journal.
Her class is like hard though.
Yeah, so the question I'm asking you
Our
is
class
this last
still
question
talking
down here,
about
this
it.
ranking task. Take those 6 graphs that we just talked about, displacement. Now you're talking about the distance traveled, aka the step count. Rank them on that from the greatest step count to the least. Who's got the most distance covered? I've only heard from like 6 people so far, but it looks different. So run that by your neighbor if you're unsure. Based on the graph, during the time that it's graphed, how far does it go?
It's not really numbers anymore. It's like this one is, which is the distance. This we just did this one out.
All right, so like at the moment, these are the most common answers. Do you see that, or is that kind of tiny? Yeah. Okay, so these are the most common answers right now. Looks like they agree that A and B are equal, but there's some disagreement on where E slots into this whole thing. If we're looking at the distance traveled, which you should think of like the step count, then so if we're talking distance, so like right now this reads 2,334. And I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Now it reads 2,350. So during the time that we're graphing here, during the time that we're graphing, how many steps did they take or how much distance did they cover? Does that help? What'd I do? Yeah. So hey, like to clarify, I think when you're interpreting A, like zero's over there, and I'm at 25 steps, and now we hit the button to start collecting data, and I'm doing this, and now we hit the button to stop collecting data. Okay? Doesn't care about what happened before. Just look at like what is it doing during the graph. During the graph, how many steps did it take, or how much distance did it cover? And when I'm wearing this fitness thingy, is it taking steps off when I change direction? If I go 10 steps this way, and now I'm at 23 or 2,350. If I go 5 steps this way, is it going to be at 2,345, or like how does it deal with the rest? It's an odometer reading if it's a step count. And it's still kind of the same debate. I've got multiple folks with F and E equal, and I've got multiple folks with F greater than E. So that's probably the conversation to have at your area. In terms of the distance traveled or the step count, how would your step counter compare if you did what happens on graph E compared to if you did what happens on graph F? Should those be equal? Should those be different? All right, now it's kind of shifting. Now it looks like most folks have F and E equal. They have A and B equal as well. Okay? Everybody's got A and B equal, I think. Is that right? I can make that claim safely. Everybody's got A and B equal? Yeah? Almost everybody has F and E equal. So let's look at F and E. Okay? Step counter. I started at 15. I ended up at 0. How many steps in total am I getting for E? That's going to be 15. And I'm just kind of subbing in the word steps for meters because my steps are about a meter. I'm very carefully calibrated. All right. And then F, I start at 0. I go to 10. I come back to 5. What's my step counter going to read? It's going to read 15 because I went 10 and then I went 5. It doesn't care that I changed direction. It's just doing the not the displacement. It's doing the distance or the step count. Okay. So those are both 15 and they're both positive. If we're talking about the distance, there's not going to be any negative there. It doesn't care about the direction. So we're going to end up with F and E both at 15. Then C is 10, D is 7, and A and B are 0. Okay? So 15 equals 15, greater than 10, greater than 7, greater than 0 equals 0 for those. Okay? It's a terrible 15. That looks like K. Now it looks like you wrote is. Good Lord, man. Learn to write. There we go. That's better. All right. So that's what's happening on that sheet. Again, I left this middle page, page 4, for you if you want some extra practice. We're going to have a quiz on Friday of this week. So class tomorrow and then quiz Friday. We've not done a lot of these essential understandings yet. In fact, I'm in the wrong class. Let me get in the right class. So these are listed on Canvas for the constant velocity particle model. I don't know if we've been calling it that yet, but that was the stuff that we've been kind of dealing with, things that travel at a constant velocity like the buggies. Okay, you know how the motion maps look if the velocity is constant. We talked about that the other day. The intervals are evenly spaced. So things you should be able to do, given a position graph, you should hopefully be able to draw the motion map and describe the motion in words. I don't know what this other thing is yet. We haven't dealt with that. Okay? But that's the first thing that we dealt with on this worksheet was if we give you, oh man, come on. If you give you a position time graph, can you draw the corresponding motion map and you describe it in words? Can you work from the motion map or the description into the position time graph. Okay, so that's one thing to expect to see Friday. Position graph, velocity. I can find the velocity of an object using the position versus time graph. That's something you had to do on that buggy lab, right? You figured out the velocity of the buggy based on that. The rest of this stuff, I don't know about. Motion map. Given a motion map, I could sketch a position time graph and describe the motion in words. So I would say probably 2.1, 2.2, and 2.6 are probably fair game for Friday. The other ones will come from Unit 1. They will be graph skill stuff. Okay, that's kind of where we're at. So 2.1, 2.2, 2.6. Those are probably likely, I would say. Okay. Switch gears then. And I think I handed this out on quiz day, and I think I forgot about it on Monday, and that's why we didn't go right back there. This is position versus time and velocity versus time graphs. Okay. Is that what that says? Weird. Is that what's going on the backside? Why does it say there are no velocity versus time graphs out here? All right. I do. Yeah, let me find the extras. So the part of this that's of interest to me is page 3. Okay. If you need a copy of this, I have some more over here. Page 1 and page 2, those are good practice. But what I'm interested in right now is page 3. So if you want to grab that, there's copies of it over here. And you're given a data set, and then you got to graph it. And then there are a couple of definitions that I want to pull out of this page. So I'll give you a little bit of time right now. If you haven't worked on page 3, let's go ahead and hit that up. So I'll put, it does look like, some folks don't even know if it's not everybody. I'll put 7 minutes on the clock here because it's kind of working that way. Just worried about page 3 right now.
Are you like going on to like doing homework or you just want to have the coffee? Okay. My job blue. There's nothing even blue. I like this.
All right, so we get a graph that looks something like this. And then the first question to you just wants to know what's going on there from time equals 4 seconds to time equals 6 seconds. Okay, so what's happening there? And then a little bit of the more important question, how do you know? Okay, so fire that into the pear deck if you would.
Because if you like slowing down, like if you just gonna stop, you have to like slow down. So
Oh,
if
yeah.
you just crash and out.
all at once.
Do you think? Like you really have to slow.
But he had to stay at one. So it just
Yeah.
Add in a little bit of that how do you know to that too, if you would, please. Try to keep it to a tweet, not a college entrance essay.
so it would so if it goes down this way, it's just going down.
Yeah.
Like if it goes up this way. So like right here, is it going faster than right here? But or is this going faster than that? Is it just whatever looks steeper? Oh, I look at it like that. Oh, there we go. I'll show
So
you.
he just supposed to be covered.
All right, so let's take a sniff at
Yeah, I covered more distance.
pear
so
deck.
short of a long time.
So skaters at rest, position doesn't change even though time is still going. It stopped and the speed was constant for 2 seconds. Skater isn't moving, and we know that because the distance stays constant at 4. Okay. Is that true that the speed is constant during that time? Run that by your neighbor real quick. So I'll give you a true false there. Speed is constant from 4 seconds to 6 seconds here. Bruh. Perda. So over on the pear deck, true or false to the claim that the speed is constant from time 4 seconds to 6 seconds.
I still think he just like fell. And then he got back I wouldn't like this.
Wait, but if you stop.
Or like if you
All right, majority rules and whatnot. So we got 17 friends saying, yeah, that's true. 18 friends now, sheeple. And then 4 saying false. So constant. That means it's not changing.
I think he like went up.
You're at rest, what is your speed?
Like went up again. And he stopped at
0.
the rest, and
If you're
he
staying
got
at
back,
rest,
stopped at the ground and then
Still 0. Okay. So yeah, so constant speed in that region. Constant speed is 0. You might not intuitively go for that because it's not moving, but yeah, it's got a speed. It's 0. It's not changing. Also, what's the shape of the graph in that region? This position time graph is what? There you go. Sit next to somebody wise. They're horizontal. Okay. So at rest, position versus time graph is horizontal. Horizontal lines have a slope of 0. Slope on a position versus time graph is velocity. Therefore, the velocity is 0 there. 6 to 10 seconds. Okay. What the heck's happening then? There's some variety. Good. Make sure that you're talking about the motion and not just the shape of the graph there, okay? What's going on there from 6 to 10 seconds in terms of the motion? If you're watching it, all right, so we're getting some options out here. So skater's moving towards the negative direction, declining graph, skater went backwards maybe. Hashtag he is moving the opposite direction because there's a negative slope, moving backwards in the opposite direction. So a little bit of variation on the description there. What would be preferred? Opposite, backwards, negative in terms of direction. Run that by your neighbor real quick. Don't make up words, Maddie Kirsch. What are you doing? That's because it's not a word. Nobody knows how to spell that. You're making it up. All right. What do you think is happening during the time interval 6 to 10 seconds? Is it slowing down? Let me throw that question to you. Is it slowing down there? Okay, run that by your neighbor, and then let's get a yes, no out of that. So my question right now, is it slowing down? Oops, sorry. Is it slowing down? This was very 50-50, but now it's not. So have a little quick chat with your neighbor about your evidence to support the claim that it is slowing down. All right. Sorry to punk you like this, but Burbage just said some smart stuff. What's your evidence to support the claim that it is not slowing down? You said it's doing what?
Going the same amount.
Yeah, what'd you say that amount was?
A meter.
Is that right?
In 2 seconds.
So 2 meters in 2 seconds,
Yeah,
1
yeah,
meter
yeah.
every second?
Yes.
Yeah. So she said it's going 2 meters in 2 seconds, 2 meters in 2 seconds. That's the same. Okay, that's got the same slope there. 2 meters in 2 seconds in the negative direction. So it's got a constant speed. It's not getting slower. That it has a negative slope here just tells us the direction it's going. It's going negative 2 meters every 2 seconds here. So is it slowing down? No. Negative 2 meters for every 2 seconds, aka negative 1 meter per second. Okay. She's mic dropping the Chromebook's going away, so we'll call that good for today. Tomorrow I want to distinguish the terms average velocity from average speed. Hey friends, I got a picture for you here. Okay? How many stadiums do you see?
1, 2, 3, 4, 5, 15.
That's
15. 15. Right? Because there's a big one that goes around all these little ones. Oh. That's the Indianapolis Motor Speedway. Your task for tomorrow is to come in knowing the fastest average speed of the winner all time for the Indy 500. Okay, figure that out. So track record, what's the greatest average speed for the winner of the Indy 500? You too, Amir. Whoa. Look out. It's a hurricane.